It's time to get going. Good morning, everybody. Welcome to another wonderful morning of chemistry, Chem 1211, with your host, me, Dr. White. Got a lot to do today, so I better get started. A couple things. First of all, I have uploaded this morning your lab scores for Lab 1. Uh, One of the things, and I'll mention this in lab tomorrow or Friday, depending on which day you have, is remember, there's no such thing as a dumb question in my world. Therefore, always feel free to ask, why did I get this score in a lab? I usually entertain those questions either in my office hour or after lab, not here during the lecture time, because that way you can do it in sort of a private way. And I will be always willing to explain why any of you got the scores you have. Unfortunately, with the labs, the way I do it, I don't actually hand back a lab where I mark off what's wrong, but hold on, emergency, dirty glasses. Oh, that's better. By the way, I think I mentioned it. You get these from Walmart, and I don't get any kickbacks from Walmart. They're microfiber cleaning towels. I think $4 or $5, and they do a great job on your glasses. All right, back to what I was talking about. So I can't really hand back the labs. In the test, I'll be doing something different where you'll know how many points you got for each question. That I do able to do. But then again, you can still ask why you got things wrong. All right. Another thing, one of your colleagues asked about the lab we're doing on Thursday or Friday. Now, I post the actual lab assignment with my lab and reference to Beyond Lab Z on usually Tuesday or Wednesday before the lab. That way you'll have time to sneak in some more blueberry tea. No, have time to download it, take a look at it. You don't have to do it yet. If the lab is later in the week and you already got it, then guess what? Wait until I go through the lab and the lab time, and you'll understand it more. Like this week's lab is an exciting lab, calories in a nut. And you'll learn about something quite exciting that the first time I did this lab, whoa, it excited me. Got me, I was just, wow, I can't believe that's happening. All right. Let me find, hold on one sec. Hold on while I log into Blackboard. Or don't hold on. Just don't fall off. Oh, it's Awful Humor Wednesday. Look out. All right, does everybody see test number 1 information on your screen? Thumbs up, people, or nod your head, people. All right, I posted this yesterday, and let's go through it. A week from today, I'll be giving test number 1. It'll be online. The way I do it is I will post in the assignment area Blackboard test number 1. It'll be password protected PDF file, meaning you can't open it up yet. And then sometime Wednesday morning, I'll send out an email to you with the password. Now, I usually do a couple versions of the test. So depending on your name in the alphabet or how I do it, you'll get a different password. Like I think test 1, I usually have 2 versions. And you'll use the password for your version. I might be real sneaky and call them versions A and B. And you'll open that and do your test. And you should take about 40 minutes. If you take a little longer, I'm not going to get upset about that. What I will ask you to do is then, and I'll talk more about this on Monday, next Monday, I'll ask you to upload it to the assignment area of Blackboard by the next morning, 10 a.m. I think I have it set for the deadline. That way, if something comes up, say you lose internet service or you have to go into work because of an emergency, they need you, this covers all that. And things like that happen with the environment we're now living in. You should not cheat, because if you do, and when I send out the email with the password, I'll remind you, I will do what's in my syllabus. You'll get a 0 for that test. You'll also not be able to use that as a drop test. And I will write a letter to the Dean of Math and Science, my dean, and to the Dean of Students about cheating. I've done this in the past when we weren't online. So please don't. And I'll talk more about this on Monday about not cheating, but Dr. White's a power user on computers, and I got a PhD, so I know how to think real good creatively. And therefore, I've designed tests that I know if students are cheating. So please don't. Now, let's talk about test one. It will cover chapters 1 through 4. Test one has 11 pages, including important information. That means in this test, I'll have all the temperature formulas. You don't have to memorize that. Everything else you do. I will, it has 27 problems, relax, and it has 7 multiple choice. I think they're 2 points each, and other short answer problems. And you will be given a periodic table that you can download from the assignment area. That's the one you should use. You should not go on the internet or have one with the names of the elements on there. I consider that cheating. Now, I will review the material on test one this Monday. And we will have, even though I'm having you download and take the test next Wednesday, we'll still have our regular Zoom meeting here where I'll lecture on other material. Now, one of the things I will do is during the test time, I will log on periodically to my email. When I do tests let me get Jessica, hold on one second, I'll do your question. When I do test at face-to-face at COD, if a student has a question, I answer it. I won't give you the answer to problems, but if you have something you're confused about, hey, why not ask questions so you're not confused? I will check my email, so if you have any, email me. And yes, I'll be checking all day. All right, first of all, when you turn in the test, you only have to do the pages of the test where there are questions. You don't have to do important information, and you don't have to do the periodic table. If you want to, I don't care. It's all in one, or you'll have it all in one file. You'll make it, but you don't have to. Now, for those of you who don't have a printer, you'll be able to read the PDF file on your screen of your tablet or computer, and then you can just take a piece of paper. Don't rewrite the questions. I'll say that again in slow motion. Do not rewrite the questions. Just write down your answers. Make sure when you do that, you put your name on the sheet and also your signature, please. And then say for problem one, you'll put 1 on your paper if you don't have a printer, and put your answer, then 2, 3, 4, and 5. Oh, by the way, for those who with and without a printer, when you're writing your answers down, do it clearly so I can see what you're writing, because you don't want me guessing. What is that? Okay, and let's see. Oh, well, Jessica, next lab, you don't have to rewrite the questions. Good practice in penmanship. My first grade teacher would be happy. They still do that, teach the alphabet how to, well, they just do, someone told me they don't do cursive anymore in schools. How sad. How do people, at least do they teach them how to write their name? Some of you should see when people write their name. All right, two more things. One, underneath the test, where it says your name, there will be on test one, and it'll also be on the other test. Please use proper significant figures for all calculated answers. If you get the right answer, but you don't use the right significant figures, I will take off 1 point. That's standard. I've been doing that for eons. Ooh, I shouldn't have said that. But anyways, for a long time. And if you have 10 problems, then you could lose 10 points, which you shouldn't. I've taught you how to do significant figures for multiplication, division, and addition. We don't do really subtraction. So make sure you do that. The other thing, boy, is that good. The other thing is my tests are designed, and if we were face to face, you'd have 50 minutes, that if you've done the practice problems and studied, it should take you about 35, 40 minutes, even though you have more time. And if you need a little more than 50 minutes, feel free to use it, because I'm of the opinion, either you know it or you don't. If you don't know it and you're not cheating, and you shouldn't, you can have all day and you're still not going to get them solved. So that's the one thing on the online test. One thing, and nobody raised their hand or say anything in chat. Those of you who have, in the past, we used to call them blue card students, special needs students, take the time I have already told you to take in emails to you. All right, any other questions? Oh, when will the test be due? You'll see I have it due, I think it's 10 a.m. Thursday morning. So you'll be able to download it after we have our lecture on Wednesday, and you'll have plenty of time to finish it. Like I said, if you've done the practice problems and you've studied a little, it should take you about 35, 40 minutes. If you haven't, well, you should do the practice problems. Hint, hint, wink, wink, say no more. I stole that from Monty Python's skit. I still like it. If you haven't seen Monty Python and the Flying Circus, I think some of them are on YouTube. You should watch. All right, any other questions before we get back to chemistry? Going once, going twice. Quick commercial from the host, me, Dr. White. Don't forget, tonight at 6 to 7:15, I have my office hour. Just show up. You don't need any appointment. Remember, it's a different Zoom. And the answers to the practice problems are hidden in the content. Let me show you a Blackboard and a folder that says practice problem answers. Is the test time? No. Some instructors do it where they have you set up your smartphone hooked up to Zoom, and so we can watch. Trust me, if a student wants to cheat, they'll find a way to cheat. Any system created, I'm sure I could cheat with a little practice. And in a classroom, only once or twice have I been fooled by students. Usually I catch it. And since we've gone online, I have put secret things in there to know if you're cheating, secret stuff. And I mean it, I really got inventive. That's what happens when you have an instructor with 10 US patents. I can be very inventive. All right, let me do one quick thing.
Hey, Dr. White.
Yes.
On Monday, I tried to get into the office hours and the passcode wasn't working.
Well, I think what you did was you have to go to a different Zoom login. Look at the syllabus, first page, or look on.
Yeah, that other password wasn't working, which was the
AMINE.
AMINE
I'll
E170.
check it again. later after class, but it should. If not, I'll send out an email. But other students logged in, so did you capitalize things, or I don't know if it's case sensitive.
No, it was all lowercase.
Okay, I
It's
think I made
requested.
that. Make sure. Oh, let me show you something real quick. For this one, you see on your screen after it says login information. Can you see that now? Hold on.
Yeah.
All right. All you have to do is take in that whole HTTPS all the way across to 09, copy that and put it into your browser. You don't need a password. Okay?
Okay, work. Thank you.
If not, I'll check the email tonight because I don't always have it on. All right, let me answer one more question. You go to course information. Can everybody see it online? Do you see where it says practice problem answers? That's where you find them. Let's find out. Maybe somebody stole them. No, there they are. See? Dr. White tries to help students by thinking of everything. All right. With that, let me clean up a few things. I don't need you. I need all of you. Everybody should see chapter 9 on your screen. Good. All right, let's get to work. Not that we haven't been doing stuff. Now, on Monday, we were talking about where are the electrons? And this you should know how to use. In the past, I used to have students memorize this table, but now I will put that important information, but you have to understand how to use it. And electrons are found in shells, which we call electron shells. I see a question, hold on. Oh, someone just reminded me something bad, Dr. White. I forgot. All right. Thank you very much, Gabrielle. All right, I forgot to, boom. Well, I shouldn't be violent to myself. Quick, call my parent. Well, anyways, that was wrong. But anyways, all right, let's get back to the electrons. Where are they? I hope they didn't run away. See, I told you it's Awful Humor Wednesday. That was pretty awful. All right, everybody see electron shells on your screen? I hope you do. Thank you. All right, now, where are the electrons? The electrons are in electron shells. The electron shells are approximately, all electrons in a shell have approximately the same energy, not exact, approximate, are approximately the same distance. Shell 1 has a fancy name. First shell is 1, second 2, third 3. The last shell I'm talking about in this class is 4. One is the lowest energy of all the shells. And as you go down the table, it gets higher. We're on this table. 4 is the highest energy. And I'll talk about that in a little while. Now, in shell 1, it has one subshell. And this is something you have to know how to use, and I'll teach you that today. In shell 2, there's 2 subshells. Shell 3, 3, shell 4, 4. Ooh, is that difficult? So shell number 1 has 1 subshell, shell number 2, 2, shell 3344. Now the subshells are called SP, D, and F. And I really should change that to, it's right as I have it, but still, I'll call them subshells for this class. And you should know, understand this table. I will give you important information. Test number 2. What I'm talking about today is material that will be on test 2. Speaking about material, tomorrow and Friday, I'll go through chapter 3 problem set. And this is, again, the lowest energy, subshell S. As we go down this table, F has the highest energy. And S, you can only put 2 electrons in. P, you can only put 6. D, 10. F, 14. And that's all you can do. Why? I don't know, but that's what chemists found, and that's what Mother Nature did. Now, when we have an atom of an element, in the center nucleus has the protons and neutrons, and all around it in the electron cloud, in the shells and subshells, are the electrons. Well, the question is, where are they? And that's what I'm going to teach you now. Now, the way we do that is what's called the electron configuration. And I'll never ask you on a test, what's the electron configuration, but you have to know how to do this. It's a statement of how many electrons an atom has in each of its subshells. And it uses numbers and letters, which reminds me, I have to open up something really quick. Maybe really slow. We got so many things open on this PC. Here we go. All right, everybody see a white screen? Thank you. All right, so sometimes I'll write give the electron instead of draw. So on a test, 3 or 4 points, depending on my mood. Remember, we're talking about test 2 now. And the first one, let's do carbon. So how do you do this? First of all, you have to know how many electrons you're dealing with. And how do you do that? You go to the periodic table. Hopefully everybody sees the periodic table on their screen now. And look at carbon. How many electrons total does carbon have? Look in the upper right-hand corner and you see 6. So I now know, and you don't have to memorize this because you'll have a periodic table for test 2 also. So we now know we have 6 electrons. Now over here, let me do something that you will have. And in class, you'd be watching me do this on the whiteboard. Well, it is a whiteboard. It's White's whiteboard. Oh, it's really awful, awful humor. Let's see. I should have put this a little over, so I'll do this. I use shorthand. This is number of electrons. And now, how do we do this? How do we draw the electron configuration? Remember, energy, this is lowest, and this is highest energy for both tables. When you're putting in the electrons, you always start at the lowest energy shell and subshell, and then fill it in and go down the list. So the lowest shell is 1, and the first subshell in 1, the lowest energy, is 1s. All right, quick thing. A subshell is designated by a number and a letter. I'll say that again. A subshell is always designated by a number and a letter. So what's the first subshell in 1? 1s. Number, letter. I'll say that in slow motion. Number, letter. Everybody got that? Let's see how we do that. So the first shell and subshell, or first subshell, lowest energy of both is shell 1. Shell 1 only has one subshell. How many electrons can I put in there? 2. Well, I'm going to do that. How do you show that? Superscript to the right of the letter, I put the number 2. Well, am I done? No, this is 2 electrons. I need to put in 6. Now, how many subshells does shell 1 have? 1. How many electrons can I put in it? 2. Well, I filled it up. Well, it's full. Now I have to go to the next shell. What's the next shell after 1 in terms of lowest energy? And the answer is 2. What's the first subshell in 2? Well, it's always going to be S. How many electrons can I put in 2s? Maximum 2. Well, am I done yet? No, 2 plus 2 is 4. I have to get to 6. Why? Because that's how many electrons carbon has. How many subshells does shell 2 have? And the answer is 2. The first one is S, and the second one is P. So I'm going to go to the second one, and that's 2P. Remember, subshell is a number and a letter. Now, how many electrons can I put maximum in P? And the answer is 6. How many do I have to go? Well, 6 minus 4 is 2. So I'm going to put 2 in. And this would be your answer right here. Not with that in there. And be 1s2, 2s2, 2p2. Now, we'll learn later on, knowing where the electrons are in which subshell of which shell helps you understand why that element reacts to make certain compounds, which is quite important. The electron configuration and something else I'll teach you helps us understand why water is H2O, not H5O7 or anything like that. And that's the importance of the electron configuration. Now, these two charts, I used to have students memorize. but I don't. Those will be given to you important information. Thank you, Dr. White. You're welcome, because I no longer test your memory, or at least a lot of it. I'm testing your knowledge of chemistry. Now, let's go through what I just did again so you can see how I did it. All right, question is draw the electron configuration for, and you're being asked to do carbon. First thing you have to do is from the periodic table, look at the atomic number that tells you how many electrons. E is my shorthand, or sometimes E with a line, shorthand for electrons. So I know I have to do a electron configuration for 6 electrons. You fill electrons by starting at the lowest energy shell and subshell. The lowest energy shell is always 1. It has 1 subshell, and that subshell always start the lowest is going to be 1. So 1s. How many electrons maximum can I put in 1s? And the answer is 2. So I did. Well, how many electrons can you put in at 1s? 2. Well, I filled it up. Now, what do? Oh, shell 1 only has 1 subshell, and I filled it. So what do? I go to the next lowest shell, which is 2. 2 has 2 subshells. What's the lowest subshell in 2? Always start at the lowest energy and go down, and that would be 2s. Remember, a subshell, S is actually designated for a shell and subshell number letter. So I have 2s. How many electrons can I put in 2s? Well, any s orbital, 2s, 3s, 4s, whatever, you can only put 2 electrons in. And I use the superscript to show I've done 2. Well, I've got 2 here, that's 4, but I have to do 6. What do? Because S, 2s or 1s, I can only put 2 electrons. Well, now I look over here and say shell 2, I can have 2 subshells. The first shell is S, the second, or 2s, the second one is 2p. Well, I've got that. How many electrons can I put in 2p? Max 6, but I only need 2 more. So I put them in there, superscript. Those 2 plus 2 plus 2, hopefully is 6. It is. And therefore, I now have accounted for all 6 electrons. And that's how you do it. Now, think of the electron configuration. Hold on one second. Everybody take a deep breath. Let it out. Take a deep breath. Let it out. The first time I learned this, what the heck is going on? And if you're in that mood, that happens. It happened, Dr. White, when I was an undergrad. I'm going to go through some more examples after the break. And plus, I gave you practice problems to do before test 2, and I'll go through that like I do always. And with that, come back in 5 minutes, depending on your clock, 10:55 or 10:56, and I'll see you in 5. I'm going to go stretch. All right, ring, ring, time to start again. Let's get moving. All right, everybody back? I think so. All right, quick thing. One of the things I didn't mention, if you look in Blackboard for, and I've only done the first lab, I think there are 2 or 3 of you, and I got to get an email out today or tomorrow. I'll try and do it. Sometimes when you upload stuff to Blackboard, it doesn't work out. There's some problem. And I'll see a little blue dot in I have a screen that comes up, shows when a student has submitted something. And if you don't have a score there in lab 1, try uploading it again. If you can't get to that interface, let me know and I'll open it up again so you can upload it. And that way I'll grade it, your lab. Also, I'll check probably Friday or Saturday. All of you should, and most of you have, don't forget to have the signature form filled out and uploaded also to the assignment area of Blackboard. I don't give any points or grades on that, but I will send out emails for those who don't, because if you don't have it by next Wednesday, you can't take test number. Well, you can take it, but I won't grade it. I'll give you a 0. And that's in my syllabus, so please do that. All right, let's go back to electron configuration. Where are the electrons? Now, let's do another one, and let's do, wrong color. Draw the electron configuration for helium. Well, how do you do that? Well, first of all, I have to know how many electrons does helium have. Also have to know what the chemical symbol is. Hold on, I see a question. I might have put it in wrong. I'll have to look. I think I did the semester 10 points or 11. I'll have to check, but I think 10, and I'll go back and check that. Thank you, Kelly, for bringing that up. All right, helium, chemical symbol He. How many electrons does helium have? And if you look in the upper right-hand corner, it has 2. Can you see the periodic table? I'll have to check my syllabus. I'm not sure. I had to switch it. I think I might have 11. I'll check. If it says 11, I think let me check my syllabus and I'll send out an email either tomorrow or Friday, because Wednesday I'm teaching all day and I have my office hours tonight. All right, so helium has 2 electrons. So now I'm going to come back here and I know I have 2 electrons. Piece of advice. I have learned from taking more tests than you've taken in your career. By the time I graduated, got my PhD, boy, I took a lot of tests. And I found the more I write down on the paper that I'm taking the test, the less I have to keep in my head, the better my test scores are. I call that let the paper do the thinking. So I put down, you don't have to, but it'll help you do better. How many electrons do I have to deal with? 2. What's the first shell? Let me move this out of your way, or out of my way. And the first shell is 1. Because remember, you go lowest to highest. Somebody's ahead of me already. All right, so I have shell 1. What's the first subshell? Remember, subshell is a number and a letter. And you start with S, always go lowest to highest, so it's 1s. How many electrons can I put maximum in 1s? Well, the answer is 2. I'm done. That was easy. Now, Dr. White likes to share the fun, and I will. Let's do C. if I can spell. And nitrogen. Draw the electron configuration for nitrogen. Now I'm going to help you out. The first thing you have to find out is how many electrons does nitrogen have? And nitrogen's chemical symbol is N. You should have learned this by now. If not, get the word. And here it is in the periodic table. And if you look at the atomic number, the number on top, it's 7. So I now know nitrogen has 7 electrons. And it's your turn. You try it. You will be given these 2 tables up here. That's why I'm allowing you to see them too. So you can do it. Get to work. Am I being a taskmaster today or what? If you're still having trouble, that happens. You'll get the hang of it. Was there smoke coming out of everybody's ears? Just kidding. When you're done, give me a thumbs up. For those of you without your cameras on, do the emoji. I think I'm pronouncing it right. I still wonder, and I think I know why Zoom doesn't have a thumbs down too. All right, I think everybody's done. Let's do this. All right, we know nitrogen has 7 electrons. How do we know that? We looked on the periodic table. What's the first shell? Lowest energy is 1. What's the first subshell in 1? It's 1s. How many electrons maximum can I put in an s orbital, whether it's 1s, 2s, 3s, or 4s? And the answer is 2. Well, how many subshells does 1 have? And the answer is 1. Ooh, I just wiped it out. Is 1. And I filled it up. So now I go to the next energy shell, which is 2. 2 has 2 subshells. What's the first subshell in 2? 2s. How many electrons can I put in 2s? And the answer is 2. Well, am I done? No. 2 plus 2 is 4. I have to get to 7. I got work to do. How many electrons maximum can I put in 2s? Well, any s orbital, the answer is 2. Hold on, getting messy up there. So I can put 2 in any s orbital. I have 2. Now I filled it up. How many subshells? Let me finish and I'll get who's ever asked your question in a second. 2 has 2 subshells, and the second one is P, because you always go lowest first and then go to the next highest. So a subshell is a number, 2, and a letter, 2P. Now, how many can I put in there? 6. But I have 7 I have to get in. 2 plus 2 is 4. That means I have 3 more electrons to add. How many max can I put in P? 6. But I only have 3, so I'm done. And therefore, the electron configuration for nitrogen element is 1s2, 2s2, 2p3. And that's how you do it. First of all, someone asked, does it matter if the letters are capital or negative? I think you meant lowercase. For the subshell, I think they're normally, when you type it out, capital, but Dr. White doesn't care if you do lower or uppercase. I'm not going to take off points because you got the wrong case. Quick educational thing. First of all, I should tell you, Dr. White is that close to the person who's grading the test, me. I don't grade tests like saying, ooh, how many points can I take off all these students' tests? No, I'm grading it. Is it right or wrong? I hope it's right. But if it's wrong, I will take off points, but I'm not going to nitpick. Do people know what nitpick means? I'm not going to try, ooh, where can I find excuses to take off points? I know some instructors are like that. Dr. White is not. All right. Hopefully that answers that question. Yep, lowercase. All right. I've got a couple. Now, someone asked, are you supposed to leave spaces in between or not? And the answer is, if you leave a space, I don't care, as long as the space doesn't put part of your answer on the next page. In other words, if it's close together and looks like it's right, I'm going to give it to you. Now, someone else asked, how do you know when to switch from S to P? And that is when that subshell is full. S, you can put only 2 electrons. So if I put 2s, I put in my 2 electrons, it's full. Like when Dr. White was this Sunday after picking out on junk food, I was full. Yeah. Anyways, in 6, I got ahead of myself. In any p orbital, like 2p, once you get up to 6, you're full. And the other ones, 10 and was it 14? Let's do one more, because repetition is good for your soul and your grade. Now, do the electron configuration for sodium. Let's see, I have a question. You're welcome, everybody who said thank you. And remember, and I do practice it, and you see me do it live on camera and also in my recordings, which I'm still alive in those, sort of. But anyways, there's no such thing as a dumb question in my class. All right, how do you do the electron configuration for sodium? Well, I look at that and say, well, in order to do electron configuration, which is how many where the electrons are, how many electrons does sodium have? Well, I look at my periodic table, sodium, chemical symbol Na. That comes from Latin, I think, for natrium, the Latin name. But anyways, how many electrons does sodium have? I'll give you 1.8 seconds to figure it out. Oh, I gave you more time. Time's up. Upper corner, atomic number 11. Sodium has 11 electrons. So now I'm going to go back to my problem here. And I know I have 11 electrons to put in. And I'm going to get the tables back for you. And you try it, and then I'll do it. Go. Remember, draw or write the electron configuration for sodium. Oh, my heart feels so good. I see everybody working on it. That makes Dr. White happy. See how easily I'm pleased? And when you're done, give me a thumbs up. I see some people are, Doesn't it feel good? You're starting to get the hang of this. If you're still having problems, that happens. Always feel free to come to my office hours or ask me after lab this Thursday or Friday, depending on which day you have lab. Don't forget, the lab we went through last week, the density lab, is due tomorrow for Thursday's lab people, Friday for Friday's lab people. Again, don't forget, the lab that you did last week on density that I showed you is due tomorrow for Thursday people. It's due Friday for Friday people. Anybody need more time? Thumbs up, people. You all done? Yep. All right, let's do it. See, somebody already beat me to the punch, but let me do it. All right, we have 11 electrons. The table's up above, but what's the first shell? 1. What's the first subshell? S. How many electrons can I put in any S orbital subshell? 2. How many subshells in 1? 1. I filled it up. So now I have to go to the next shell, 2. What's the first subshell in 2? 2s. Remember, subshell is a number and a letter. How many electrons can I put maximum in any S subshell? And the answer is 2. Now I filled it up. How many subshells does shell 2 have? And the answer is 2. And what's the second one? Don't get dizzy, I'm moving up. It would be P. How many electrons maximum can I put in P? 6. And a subshell is a number and a letter. 2P I can put in 6. Let's see, I have 2 plus 2 plus 6. That's 10. I need 11 electrons. Uh-oh, what do I do? Well, if you look at shell 2, I can only put in, I only have 2 subshells, S and 2S and 2P. I've filled it up. So now I have to go to the next shell, which is 3. 3 has 3 subshells. What's the lowest energy in 3? 3S. And now I go to 3S. I have 10 here. 11 minus 10 equals 1 more electron to go. S, 3s, 2s, or 1s, I can put a maximum of 2 electrons, but now I only need 1 and I'm done. So for sodium, the electron configuration is 1s2, 2s2, 2p6, and 3s1. And that's how you do it. When I say fill it up, that means that's the maximum amount of electrons you can put in there. In any s orbital, you can either have 1 or 2. You can't have 3. By the way, if anybody can find a way to put more electrons in a subshell than I'm telling you, let me know. We'll be rich beyond my wildest dreams. And that goes beyond my own island in the South Pacific, my own fighter jets for me to play in, my own Lamborghini, my own Ferrari, and a whole lot of others. It goes, you can't. All right. Now, someone asked, can we do another one? The answer is yes. But before I do that, can you guys keep a secret? It's time for a gift from Dr. White. Not a big gift, but a very nice gift from Dr. White. Are you ready for that gift? Let's go look at the periodic table. Now, when you get beyond argon, all of a sudden things break down. Some of the rules, like for iron and all of those, even gold, break down. Sometimes you put electrons in a 4s before you fill up 3. And you have to learn these exceptions. And it's a waste of time for this class, and even for Dr. White, and I'll get to somebody's question. So here's my gift. I will only ask you to know how to do the electron configuration up through magnesium, atomic number 12. My gift to you is I'm only going to ask you to know how to do the elements, the electron configuration up to 12. Remember, it's a secret. Shh, don't tell anybody, because if you do, if you tell anybody, people think I'm nice, and no, I want people to think I'm mean and nasty. I don't know if that works or not, but that's my gift to you. You only have to know for the test and final for my class up to 12. And why? Because there's, first of all, other things that are more important I'd rather you spend time on. You could spend the next 2 weeks learning the exceptions and still get it wrong on a test. I don't know them. If I do chemistry and I do it, why should I ask my students? If I were another type of chemist, like a physical chemist, I'd know them more. But I'm an organic chemist. I'll teach you other stuff which I think is more important. I'd rather have you spend time on. So that's my gift to you. All right, had a request. It's Request Wednesday. Let's do one more. I have the periodic table. I'm going to make you work for it. Why don't you do neon? What would be the electron configuration for neon? Now, I'm going to fade prompts. Here's the periodic table. I'll give you 10 seconds to figure out how many electrons. I'm actually watching my watch, so I know 4, 3, 2, 1. Time's up. Neon, Ne, has 10 electrons. On a test, I won't have all these, usually 2 or 3 I'll put down, and do the electron configuration for neon, 10 electrons, and let me scroll up. So now you have this, and do it. That doesn't sound polite. Could you please work on that? That's better. Get it done. I see someone knows how to do their electron configuration. And when you're done, give me a thumbs up. Ooh, I see smiling people out there. You're getting this stuff. Aren't you proud of yourself? This is tough chemistry. I had trouble with it at first and finally clicked in, but I had an instructor who didn't do the kind of examples like I do in class. He just showed it and you were expected to figure it out on your own. Dr. White doesn't like to do that. I'll give you a little more time. Anybody need more time? I guess not. Let's do it. All right, we have neon. How many electrons? Well, you figured it out, 10. What's the first shell? 1. What's the first subshell? 1s. How many electrons can I put in any s orbital or subshell? And the answer is 2. Oh, I did it. How many subshells in 1? Well, 1. And if you don't believe me, it even says it on your screen. 1 subshell. Well, now I have to go to the next subshell, next lowest energy. That's 2. Remember, 2 has 2 subshells. The lowest energy subshell, it's a tongue twister. Sally cells, no, I won't do that. But anyways, is 2s. 2s, how many electrons to fill up? As someone asked, what does it mean fill up? It's the maximum. If you have a 2-quart measuring cup, you can't put in 5 quarts of liquid. It only has 2 maximum. Well, for electrons, S has 2, P has 6. Because of my gift, you don't have to worry about D and F. Oh, did I give that away? But anyways, how many electrons can I put in 2s? Any s, the maximum is 2. Well, 2 plus 2 is 4. I need to get to 10. Well, how many subshells in shell number 2? Well, if you look at this table, and the answer is 2, the second one would be 2p, which I can put up to 6 electrons. And here I have my 2p. I can put up to 6. I have 10 total electrons minus 4 I'm showing. Oh, it's 6 too. So I now have 1s2, 2s2, 2p6, and this is the answer. And you get your 3 points or 4 points, depending on how I write that in a test. Remember, this is test 2 material, not test 1. And that's how you do it. And that's electron configuration. And my best advice to you is do the practice problems. Don't do them yet because you can start them, but make sure you've done the 1 through 4 for test number 1, because that's coming up in a week. Test number 2, well, that's a couple more weeks down the line. And we'll go over practice problems for that in lab. All right. Now, click. Will the next couple of slides be on test? No, but I still want to go over. I used to teach this and I thought about it, and I'd rather spend time on other things on orbital instead of going through the orbital diagram. So I will not put that on a test or a final, but I still want to cover it in case someone else comes up to you and taps you on the shoulder, says, could you show me, do you know what an orbital diagram is? At least, oh, I heard about that in chemistry. I don't think that will happen, but you never know. Now, an orbital diagram is a statement of how many electrons an atom has in each of its orbitals. Now, orbitals are similar but different to subshells. And here you use numbers, letters, and boxes. And let me just give you a quick example. Carbon, 6 electrons, switches off. And now, how do we do this? First shell is 1, it's 1s, and we show a box. And 1s can have 2 electrons. We show that by spins. And in a box, you always have up and down. Next one would be 2s, because 1s only has 1 subshell. And each box, which is an orbital, again, switches off. I can put 2 electrons, I show them by opposite spin, and now I get to 2p. Now, 2p can have 6 max electrons. Each box can only have orbital 2 electrons, so 2p has 3 boxes. And because of the Bus-Seat rule, or you also known as Pauli exclusion rule, you put 1 electron in each box before you double up. It's called the Bus-Seat rule because if you get on a bus, you know nobody on there, you're first going to look for an empty seat before you sit with someone. That's just human nature. Now, I have 3. I have 2 plus 2, and I didn't need 3. I'm thinking so. And now I have 2, 4, and 6. And that's how you do it. This will not be on the test. And it must be true. It's on your screen on your computer. I said it was awful humor, and that's how you do it. And I'm not going to ask you to learn this, but I did show it to you. All right. Now, when we look at the periodic table, turns out there's certain trends uh, that properties increase or decrease as you move across a row, or if you move up and down in a column. And I'll talk more about it later on this semester when we get into some other stuff, and I'll get into that. Valence electrons. If I had a dial, not a switch, first of all, switch is on, and it only goes to 10, I've just turned it to 100. I stole that from the movie This is Spinal Tap, where they said they play so loud, their amps only go up to 10, amplifier, guitar, they turn it up to 11. But anyways, this is important. Hint, hint. Everybody get the message. What is a valence electron? You should know. The valence electrons are the electrons in the outermost energy levels, in other words, shells and subshells of an atom. Another way of saying it is the outermost electrons of an element. So these are on the outside, very outside. And these are the electrons that are dealing with, well, I'll teach you chemical bonds. So of any element, these are the most important. You should know, if I ask on a test, what's a valence electron? It's the outermost electrons of an element. I'll say it again. You should know, if I ask on a test, what's the valence electrons? Those are the electrons, the outermost electrons of an element. And how do you find that? Oh, I even wrote it on this slide, know this. Now you know I'm serious. And how do you determine the valence electrons for an element? You look at the top numbers, group numbers, otherwise known as the numbers at the top of the column of the periodic table, and they are equal to the number of valence electrons that each element in that column have. Again, you look at the top numbers of the periodic table, and those are equal to the number of valence electrons for every element in that column has. Now, one of the things I learned a couple of years ago, and everybody, how many of you did not learn Roman numerals? Give me a thumbs up. Oh, looks like a few people. Well, I've been saying over the last couple of years, a number of students never learned it like I did. And I think first or second grade, we started learning Roman numerals. So Dr. White will help you out. Let's go look at a periodic table, the one you'll use. Everybody see the periodic table? Thank you. All right, if we look at the first column right here, let me make this a little larger, get rid of this stuff, get rid of this stuff. And we look at the first column. You see the Roman numeral I after in front of the letter A. And I also wrote the numeric or Aramaic way of writing that, 1. That means hydrogen. Now you consider hydrogen, even though it's not an alkali metal, it still has the same number of valence electrons. Hydrogen has 1. Lithium has 1. Sodium has 1. Potassium has 1. Now, if we go to the second one, the alkaline earth metals, the two I asked you to learn, magnesium and calcium, they both have 2. Now, if you're not familiar with the 2II, meaning Roman numeral 2, I now have, and this is the actual what you'll see that you download for test 2 and use this periodic table. Now, if we come all the way over here, carbon, how many valence electrons does it have? 4. We come over here. Nitrogen, by the way, if you don't know IV, that's Roman numeral 4. And next, how many valence electrons does nitrogen have? Well, you look up here, 5. So does phosphorus, 5. You don't look at the numbers here, you look at the number. By the way, V is Roman numeral 5, but notice I wrote it in red. Now, I better share the fun. How many valence electrons does oxygen have? And then I'll tell you in a second. Time's up. Oxygen. You look over here. Oh, what's the number on the top? VI is Roman numeral 6. It has 6 valence electrons. Ooh, let's do another one. See how nice I am sharing the fun? How many valence electrons does bromine have? Time's up. Bromine.
7.
Somebody have a question? All right, bromine, chemical symbol Br. Look on the top, VII, in case you don't know it, I have it written there, is the number 7. That means bromine has 7 valence electrons, but so does the other halogens, fluorine, chlorine, and iodine. Finally, ooh, my favorite. How many valence electrons does argon have? Oh, am I working you hard today? Mean, Dr. White. See, people already got that, so I think you're all done. And if we look at argon, you need to know the chemical symbol, Ar. It's a noble gas. And therefore, look at the top, VIII, otherwise known as Roman numeral 8, which I also give you the number 8, is 8. So argon has 8 valence electrons. So does neon. Now, the one exception is helium. It has only 2, but I'll probably never put that on a test because I don't like to play tricky games. But krypton and xenon all have 8 valence electrons. Remember, the valence ooh, I'm right in the middle of the periodic table. I said it was Awful Humor Wednesday. That's pretty awful. But anyways, the numbers at the top here, like there and like there, that tells you, oh, I'm getting really awful. That tells you how many valence electrons. The valence electrons, you should know, are the outermost electrons of an element, the most important electrons in Dr. White's mind. And just to remind you, valence electrons, the representative elements, those in a column, have the same number of valence electrons. Chlorine, bromine, iodine, all halogens have 7 valence electrons. You don't have to memorize them. The valence electrons for any group column are the same as the Roman numerals or standard numeral numbers that are at the top. You should know the maximum number of valence electrons for any element is 8, the noble gases. I'll never ask anything on there. Now, the valence electrons, and this I'm not going to ask you, but chemical properties of elements are largely determined by the number of valence electrons they have. All the alkali metals have only 1 valence electron, and they react similar. All the halogens have 7, and they react similar in various reactions, which I'll teach you. So valence electrons, I think, are more important than you spending a week or 2 learning all the exceptions to the rules of doing electron configuration. And that's I'd rather spend more time on, and I did. All right, now we were talking about periodic table, and periodic table has some hidden information in there. Really? Yes. And if you look at the columns and the rows, they tell you a lot of things. One is atomic radius. Different elements have different radius. Remember, diameter of a circle, radius is half from the center, in this case, the nucleus, to the outermost electrons. And that's the, oh, I have it here, from the nucleus to the outermost electrons, which are also known as the valence electrons. Now for this, I'm going to turn the switch off, because I don't think I've ever asked a question like this on test or final, but it's still good knowledge I'll use for other things I'll talk about. And the atomic radius increases when you go down, and the atomic radius decreases when you go from left to right. So when you go down, the atomic radius increases. When you go up, it decreases. And when you go from left to right, it decreases. So if we look at a periodic table, oh, there's one. As we go from left to right, the atomic radius gets smaller. And we go from bottom to top, the atomic radius gets smaller. And that's why if we look at the halogen, fluorine has a smaller atomic radius than chlorine, than oxygen. And I'll never ask that on a test, but at least now you've learned about that. Now, ionization energy, also known as electronegativity, and I'm not going to ask this on a test, is the energy needed to remove an electron, the outermost electron, you always, from an element, atom of an element. And ionization energy decreases when you go down a column and increases when you go from left to right. So that's something I'll talk about more. Again, switches off for this slide. Another one switches off, metallic character. As you go across to the right, most elements have more metallic, and this is mainly for the center. And as you go down, it's more metallic, even though some elements are never metals. The end. And guess what time it is? It's a new chapter time. Yeah, I got a minute left to introduce. And this new chapter, I'll be telling you stuff. Now, one of your colleagues sent me an email. Dr. White, how come there are no questions, practice problems for chapter 5? Oh no, did you forget? No. There's only a few things in chapter 5 that I'll go over, and they're just 2 or 3 definitions. So am I going to write a set of questions? What's the definition of this or that? And the answer is no. So I won't. And with that, I just looked at the clock. Time flies when you're having fun with electron configuration and valence electrons. And I'm done for today. Let me remind you, 1, tomorrow and Friday, depending on which day you have lab, I'll go over chapter 3 practice problems. 2, don't forget, the density lab is due, got to have it uploaded to Blackboard by tomorrow afternoon if you have Thursday lab, by Friday afternoon if you have Friday lab. And finally tonight, I will have my office hours. Remember, use this different Zoom login. And oh, I forgot to mention, one of your colleagues Monday night was nice enough to stop by, help me out with Zoom meetings. We practiced at the breakout rooms, and it worked. And Thursday and Friday, near the end of lab, we're going to be trying something. I'm going to try an experiment with you. I'll have you go to breakout rooms and get to meet your colleagues. And also, I'll jump in there and you'll get to talk to me if you'd like to. If you don't, well, you just go, no, you don't have to do that. And with that, I look at the clock, I'm done. Be safe. I'll see you either Thursday or Friday. stay warm. I've been having a lot of fun, quality time with my driveway and snowblower and snow and shovel. Do both parts. Uh, I'll go through chapter 9 later on. That's later on. I'll tell you when. What are my office hours? They're from 6 to 7:15 Monday and Wednesday night, and it's in the syllabus too. And with that, I'm going to say, Kane Gazoon, goodbye. Hope you enjoyed today. Chemistry is fun. If I say that enough times, you'll believe me. It is. And for those of you who want, come to my office hour after labs once you got a good memory and practice how to eliminate test anxiety. And with that, I'll say once more, Gazoon, bye.